Alright guys, welcome to part 2 of the car rig tutorial. In this video we will be setting up the drive element. So when we move our drive control, our wheels will be rotating with that, and they will be able to determine their rotation value based on whatever direction and distance that you make the car travel, which is really cool. We're also going to be setting up our steering. So let's get right into it and we'll continue where we left off on part 1. So let's unhide part 2, the wheels. And let's go ahead and hide temporarily this car group here, just so we can see all of the pieces inside and take a quick look at them. So we're going to be creating joints, 4 of them. There are wheel joints, and these are going to be placed in the center of each of our wheels and on the outer edge. And they're all going to be Z facing forward as well. So let's go ahead and skin our wheels and tires to our joints here. So I'm going to grab these 4 joints. Let's go into skin, bind skin. Let's set our max influences to 1, and if we select our wheels and hit apply, and then select those again, and our tires, hit apply. Now when we grab one of those joints, it should be skinned directly to that wheel only, and we don't need to deal with any point weighting. So we can grab these pieces of mesh now and throw them in our geometry group. And now let's focus on these ball joints here. Now these are created in almost the same spot as our wheel joint, but they're pushed in until we reach our steering pivot. These joints are going to be used for the individual suspension that's driven by these controls eventually. So that's what these are for primarily, but they also get used for steering as well. So that's why we move them to that pivot position. And it's nice to have everything aligned anyway, makes life a little bit easier later on. The next thing we want to do is create these 2 steering joints here. Now those are also aligned with our pivots here, our steering pivots, but they just get moved back until they reach the steering arm pivot there, the bar that goes across. Now that we have those in place, we can go ahead and skin all those joints. Now again, all of these joints, just to let you know, are all Z facing forward, just like every joint that we have. So let's grab all of our ball joints and our steering joints, then our wheel mount tutorial mesh there. Let's grab skin, bind skin, and hit apply with max influences set to 1. Now these rear ones are going to be set up fine, but when we move this, we've got a bunch of skinning issues here that we need to fix real quick. Basically, we want just this bar moving and split between these 2 joints. So when we move this joint, we just want that half of the bar moving. We don't want to be dragging any of this arm geometry around. So let's grab this piece and this piece. Just going to grab the vertices here, and let's go into the component editor right here, and you can see that all these verts here have some influence on the steering joint. We want to set all of those to the ball joint, and then we're going to do the same for the other side. Grab all those verts and just set them to the closest ball joint here, and that's good. That's everything we need. And now when we move this, we're just getting that half of the steering bar. Alright, so that's everything we need to do there. Now what we're going to do is we're going to parent our wheel joints to the corresponding ball joints. So we're going to grab this one and parent it, this one to this one, parent it, this one to this one, parent it, and that one to that one. So basically every wheel joint to its closest ball joint. And then we're going to grab our steering joints and we're going to do the same things. We're just going to parent it to the closest ball joint right here, like that. Then we're going to parent all 4 of those to the chassis joint. So if we unhide that real quick, we can see everything all now connected. Everything should look like this. But I'm going to continue to hide this so we can deal with the next few pieces here. So let's parent our wheel mount to the geometry group. We don't need that at the moment. Now we're going to create a group that is in exactly the same position as our front axis control, right? So we got a new group there. We called that front wheel adjust. That's going to go right there. We're going to leave that for now. We're just going to create it and freeze the transforms on it. And then we're going to create our wheel controls here. And we want to make sure that these are positioned like so. And we want to make sure that the pivot point is directly below the center of your tire like this, because this control is going to follow the contours of your terrain mesh if you want to use these for that. The geometry constraint relies on the pivot. So if there's a bump over here, but everything's flat here, this control is still going to go up and it's going to make the wheel lift up even though there's no bump underneath. So just make sure your pivot point is underneath the center of your wheel. Okay, now you want to create a reset node for each of these controls as well. And these reset nodes are not going to be positioned in the same position this time as the control. They're going to be set at the position of our width joints. So our left front wheel reset is going to be at the same position as our left front width joint, and so on with the other ones. The right one is going to be over here, and the same with some rear ones as well. They're going to be just snapped to these joints. So once you have those in position, you can go ahead and parent your controls to the corresponding reset node. We're going to do the same thing with these rear ones here. And once they're all in place, you can go ahead and freeze your transforms on your controls, but just make sure that the pivot point stays below that wheel. Alright, so if we move one of these reset nodes here, it should move the control as well. Alright, then we're going to grab the front wheel resets, both of them, left and right, and we're going to parent those to our front wheel adjust. And then from there we want to parent our front wheel adjust into our rear axis control. So our hierarchy should look like this. And then we're going to connect this front wheel adjust. Let's open up the node editor. And we're going to grab our front wheel adjust and add that in here. Then we're going to grab our drive control and add that in as well. So now we're going to connect the length adjust to this. So what we want to do is use our wheel MD again, this multiply divide node that we created in part 1. We're going to add this in, and we're going to use another slot from here. You see how we already have our width adjust connected into our input 1, X. We're just going to use another slot in here to save using another node. And we're just going to take our length adjust. We're going to attach that to input. We'll use Z, that'll do. I think we're going to use another one for Y later on. Let's take output Z, and we're going to plug that into our translate Z. We're going to make sure everything should be -1 at the bottom here of your multiply divide node for your input 2s. That's all good. We can just close that for now. And now when we adjust our length, you see our controls are staying in the right place. We haven't attached our wheels yet, but the controls are staying in the right place. So that's good. Everything's working. Next thing we're going to do is parent our rear wheel resets with our controls in there. They should look like this. And we're going to parent those to the rear axis control as well. So now when we move that, they move back with it. So that's looking good. And now we're going to set up our steering points. Now these are just two locators that are positioned in the exact same position as our front left and right ball joints, right at our steering pivot. Now these are going to have a direct connection to our steering attribute. So let's load up the connection editor, and we're going to grab our first locator, which is our left front steering point. We're going to have that as our reload right. This is what's going to be driven. We're going to be driving our rotation Y. So let's add our drive control as our driver. And we're going to be using our steering to drive our rotate Y. And then we're going to do the same thing for the right side. So let's load the right one in there. With steering should be still highlighted. We're going to go and grab our rotation Y. Now because these are both Z facing forward joints, they will rotate the same. Right? There's no mirroring that went on with these joints. There's no inversion of their behavior. And the same thing is going to happen with these locators as well. They're both moving in the same direction. Okay, next thing we're going to do is we want to connect our front ball joint, our left one here. We're going to connect that directly to our steering point here. So we're going to just use a parent constraint for that. So let's just go up to parent constraint, and we want to use everything except Y again, the Y translate. So let's grab our steering point here and our ball joint. I'm just going to hit apply. So now our joint is connected in every way except translation Y. And we're going to use the connection editor here while it's open and use this control to drive the up and down motion of this joint. So let's use this control as our driver. We're going to look in here and try and find translate. Okay, so translate Y. And that's going to be connected to our ball joint. Hit reload, go to translate Y. So now that's all set up like this. So when we move this control, it goes up with it. Alright, cool. We're going to do the same thing to the other side. So we're going to grab our front steering point, then our ball joint, and just hit apply with the parent constraint. Make sure that Y is turned off. And then we're going to connect our translate Y of our ball joint to our front wheel control. So let's grab that, grab the translate Y of the right side here and the right ball joint, and we're just going to hit translate Y so they're connected. Again, we get this moving out, works with it that way, and yet it will still steer when we rotate our steering. So that's cool. So that works, everything's good there. We just need to make sure that we set up the back wheels. Now this is a little bit different the way we're going to set these ones up. We're going to be connecting the ball joint, the rear ball joints, because we don't have any steering point to connect these two. We're just going to connect them directly to our rear wheel controls here. But if you can imagine the radius changing on these wheels and the chassis moving up, if this wheel is getting bigger, this will have to move up with it. So if this is fully parent constrained to this control, this wheel is going to be fixed and it won't move up. It won't give the effect that we need in order to create the resizable rig. So what we're going to do is we're going to just constrain everything the same way, but we're going to leave out the Y. So we're going to grab our control and our rear ball joint and hit apply. So we're leaving out the Y. We're going to do the same thing with the other side. We're going to leave out the Y, but then we're going to actually connect it. We still want it to actually move with this on the Y, but we don't want it to be constrained to it, because the constraint is going to lock it in place, whereas the attribute connection is going to kind of leave it free, but will move with its parent, which is the chassis control here. But when this attribute changes and goes up, it's still going to affect this and move it up with it. So it's kind of a little weird trick, but it will work really well for this situation. So we're going to grab our control here, our rear wheel control. We're going to take the translate Y and we're going to connect it to our rear ball joint on the left side. We're going to do the same thing to the right side. Grab the translate Y and connect that to our ball joint translate Y. Alright, move those over here. So when our wheel radius goes up, you notice the entire car goes up now, and that's because we freed up that attribute and just connected it directly with translate Y instead. So next thing we're going to do is parent the left front steering point to the left front wheel reset. It's going to go right in there. And then the same thing for the right front reset. We're going to take that right front steering point and put that in there as well. Next thing we got here is these display circles. What they do is they just give you a visual cue of what the actual radius of your wheel is. So we're going to use the node editor for this. So open up the node editor. All these are just NURB circles, right? That's all these things are. They're just, you can go up to create NURBS primitive and a circle. I'll just create one real quick. That's all these are. And if you look at the attributes here, there's this make NURBS circle input here. It's kind of part of the construction history, and we're just basically attaching it to our wheel joint with a parent constraint and just linking up the radius. That's all that is. We're just linking up the radius to our radius attribute. That's what's going to happen. So I'll go ahead and link these up real quick. They've all been positioned, so you can go ahead and constrain these directly to each corresponding wheel. You can kind of see them. I hide the geometry real quick. They're all in place here. Let's grab a parent constraint here. And this one you want to make sure that all is selected. We're going to be constraining everything. So let's grab our wheel joint and then our left front wheel. Hit apply. Then we're going to do the same thing here. Wheel joint, right front wheel, apply. Wheel joint, left rear wheel, apply. And finally the right rear wheel right there. Okay, so they're all in position. So if we move that joint around, they should all move. Alright, great. Now all we need to do now is just connect up our radius. Now to do that, it's a little bit tricky because we need to grab the construction history node, not the actual transform node here. So if you actually add these, we have to find it, and it's this one here that I've already named wheel display, but it looks a little different. And if we open that up, you'll see radius on here. And these are the ones that we want to connect to our radius control. So if we add this in, we've got our drive control. So we're going to grab our wheel radius and connect it directly to the radius of our wheel display for that. And we're going to do the same thing for all of these. So we're going to grab the next one, add it, wheel radius directly into the wheel display's radius. That's all we're doing here. So we'll grab the next one, grab the drive control, and we're going to grab the wheel radius and just plug that into the radius of the display. One more to go. And grab the wheel radius and plug that into our display radius. Right, so we can close that now. So now when we set our wheel radius, we have our controls moving up and a bit of feedback for a display, so you can kind of match it to your geometry of your car. So let's go ahead and parent these to the same groups. So we're going to grab our left front wheel display, we're going to put that into our left front wheel reset. Same thing with the front wheel, throw that in the front wheel reset. And then we're going to open up our rear wheel reset. So we're just going to throw those in there. So the right one into the right reset and the left one into the left reset. We can get rid of our part 2 wheels tutorial group. And we have everything set up in the hierarchy. Now we're just going to go ahead and link up the driving. I just will add real quick that the displays are set to template mode, just in case you're wondering why you can't select those. So if you grab one of those, go into the attribute editor, you'll notice under the display tab and then drawing overrides, it's just set to template. So if you turn that off, you can actually select these. You can just turn it back on again. I just did that so you're not selecting it, because it's not really a control, it's just a display feedback. That's why that's not selectable. Okay, so next thing we're going to do here before we move on to the expression stuff, is I just want to make sure that all of our resizing is working. So if we grab our length, move this back and forth, everything looks like it's working in that attribute. Just want to double check that our width is working, and all we have is our joints moving there. So we need to do something with that to make sure that that works with it as well. These reset nodes for our controls, if you remember, and we created them at the same position as our width joints, which means they have the same value at translation X. So all we need to do is connect the same drive control outputs that we connected to these joints. We just need to connect those to our resets for our wheel controls, and everything should work like it should. So let's open up the node editor again. And what we're going to do is grab that trusty old wheel multiply divide node again. Let's just add that. And we can see it's connected here from our width adjust into our input 1x. And then the output x was plugged into the width joints here. So what we want to do with that, let's move that one out of the way, we don't need that one. We basically want to create this same connection but plug it into our reset nodes here. So we're going to grab each of these, our front wheel reset for each side and our rear ones, and we're just going to add those. We're just going to move those up here, and we're going to connect directly for the left sides. They can go straight into our width. So we're going to grab our width adjusts and we're going to plug that directly into our translate X for the left side only, right? Translate X. And then we want to go through the invert node for the other side, but we've already set that up like we set up on these width joints here. So we're going to grab our output X. I'm just going to plug that directly into our translate X. And we're going to do the same thing with this side as well. Okay, so now when we do this, now when we move our width adjust, we have our wheels moving as well. So everything seems to be working really well. Let's just set up our driving. Let's get the drive control controlling our wheels. So if you remember when you downloaded the scene file, it was a zip file, and inside it there was a text file with it, and it should look something like this when you open it. This is the expression that we're going to be using. I'm not going to explain this and what it all means. It is explained pretty thoroughly in the wheel tutorial section for the tank rig. So if you really want to know what all this stuff means, you can just scrub to about the middle of that video and it will be answered. Basically what we're going to do here is just copy this, and we're going to open up expression editor, paste it down here, paste all that code down here, and then we're just going to call it car expression, something like that, and just hit create. So now that we've got that created, all the connections are actually already made to the drive control. You can see it connected right here. So it is identical to the tank rig expression, other than the fact that I had renamed a few of the attributes. On the tank tutorial, it was just called drive, but because we have steer drive and wheel drive, I had to rename things a little bit here. So that's all the difference is between those expressions. So if you worked on the tank, you'd be familiar with that expression. Right, now that we've got that set up, we don't need the expression editor anymore. So now if we unhide the geometry, if I move this, nothing's going to happen right now still. But what you're seeing up here is the rotation value that is calculated based on our position. If we connected this directly to our wheels right now, this would look like it's driving forward and backwards. but we want to add in our front and rear wheel spin right now so that they can become additive to that before we actually connect it. That way you can still control the wheels as well as have this automate the wheels. We still want some control over those, right? So what we're going to do is open up the node editor once again. So we're going to create a few extra plus minus average nodes here. We've got actually already in the scene. So we're going to grab the rear wheel spin PMA, which just stands for plus minus average, and a front wheel spin PMA. We're going to add those in real quick. So they're right here. We're going to add our drive control to our node editor. So open that up. Select all of our wheel joints, and we're going to add those. And let's set these up. So let's do the rear ones first, and we're dealing with the rotation X. That's what we want to use to spin our wheels. So we're going to connect our rear wheel spin into our rear wheel spin PMA here. We're going to put that into input 1D0, and then we're going to take our wheel drive attribute and we're going to plug that into, let's open this up, it's not letting me plug it in. So we're going to use our wheel drive attribute and put that into wheel input 1D1. So basically this is going to be adding, if we open this up here, it's using the operation sum. So it's going to be adding these together. It's going to be taking our rear wheel spin attribute and our drive attribute, and then we can output the result, output the 1D result directly into our rear wheels. So we can put this right into our rotate X, and we get this unit conversion node here. So we can just then hit the output from here directly into our rotate X, so the other wheel. So when we move this now, our rear wheels are moving. We go to our channel box. When we adjust our rear wheel spin, we can also control them manually as well. Awesome. Let's move on to the front wheels. So we're going to do the same thing though with this. We're going to take the front wheel spin. We're going to plug that into our input 1D0, and we're going to take our wheel drive into input 1D1. So it's the same setup as this at this point. I'm just going to leave that there for now, because what we need to do is split our wheels off because they're going to be rotating in different directions. If you can think about when we steer this, one wheel is going to be going backwards and rolling one way, and the other wheel is going to be going forwards and rolling the other way. So we need to have them split off. So we're going to create two more plus minus average nodes here. We're going to create the left front drive plus minus average and a right front drive plus minus average. We're going to create those and add them. So we have those up here. And what we're going to do is we're going to connect our front wheel spin plus minus average node here. And we're going to take the output 1D and we're going to connect it to each of these into input 1D0, and same thing here, input 1D0. And then what we're going to do now is we're going to connect an attribute that we haven't really set up yet. We're going to set that up in a minute, which is our steer drive. And this is going to be calculated based on all the distance stuff of the wheel motion. We'll get to that in a moment. So we're just going to connect this for now. So we're going to just take our steer drive and plug that into input 1D. And the same thing with this one here. We're going to take the steer drive and plug that into here. And then the output of these into the wheel joint. So let's take the output 1D here and plug it into rotate X. Unfortunately, we can't reuse the unit conversion node that shows up here. So what we're going to do is just create a whole new one because they're split off. We can't reuse that. So we're going to take the output 1D and plug that into our rotation X. So now those two are set up. Now everything should drive correctly. All our wheels are driving. But when we steer this, nothing is going to happen yet because we haven't connected that up. But our steer drive does affect this in opposite directions. It affects this in opposite directions because one of these, our front drive, is set to subtract and the other one is set to sum. So what it's actually doing here is it's taking the result of our wheel spin and our drive and just minusing our steer drive value that we're going to calculate in a moment, and the other one is just adding it. So I'm just going to clear this out, start with a new canvas here, and we are going to try to recreate a little part of this expression, this part here, and this is 2 pi r. So we're going to try and find the circumference of a circle. Now we're not trying to find the circumference of the wheel this time, we're trying to find the circumference of the circle here that you see with this rotation tool, or somewhat close to it. Basically what we need to do is take the radius, which is going to be, if this is our center point, our steering center point here, the radius would be from here to this joint, From there we're going to go 2 pi r, and that's going to give us the circumference of this entire circle, the distance around it. And then we're going to be multiplying that with a fraction that we're going to get from whatever our steering value is, right? The rotation value of that, and then multiplying that fraction to the circumference to give us that arc length, the distance between those 2 points or wherever we're steering to. We're going to be taking that distance and applying it to the distance of our car as well, so that gets added or subtracted to the wheels that are actually going to be steering. Hopefully that made sense. So let's go ahead and make that math expression out of utility nodes. We're going to be using multiply divide nodes. So we're going to create 6 new multiply divide nodes here. Just going to add those in and talk a little bit about them. They're all just standard multiply divide nodes. I just named them based on the actual section of the math equation or the expression, or however you want to put it. So we're basically taking all of these nodes as little separate chunks of the math that's going into this equation right here, or a version of it. Right, so the first thing we're going to do is we're going to get our circumference. So we're going to be taking the radius value of our circle, which is the exact distance of this. So our translate x here of this joint is our radius. So that's what we're going to be multiplying to our 2 pi r. So we're going to calculate that. So the first one we want is our steer circumference calculation. So if we open that up, you can see I've already got the 2 pi written in here, and we just need to multiply that by the radius. So we're going to take our drive control, add that in here. Let's open this up, and we're going to take our steering radius. So we're going to take that and we're going to plug that into input 1x. So that gets multiplied to 2 pi, and now the output 1 here, output 1x, is going to be our circumference. Okay, so let's move these out of the way for a second. Next thing we need to calculate is the fraction that we're going to be multiplying this to. We're going to take the value of our steering rotation and just divide that by 360, and that's going to give us the fraction that we can then multiply to our circumference. Right, so we've got steering circumference fraction right here, and if we open that one up, we see we're dividing by 360. So what we're going to do is we're just going to take our steering attribute and we're going to plug that into input 1x, and when we actually multiply these things together, the result is going to be our distance, our steering distance. So we're going to take our output x and we're going to plug that into our input 1x of our steer distance and invert. This and invert part of here, you can ignore that for now. That's just to let me know that I'm also using it as an invert node for one of these other inputs. So we don't have to worry about that right now, but we're just going to go ahead and multiply these two. So we've got our first part, our fraction, and we're going to be multiplying that to our circumference. So we're going to take our output 1x and throw that into our input 2x. Now the result of this is the distance that our wheel travels around this arc, so the arc length of however much we're steering. So let's calculate the wheel's circumference, which we already know through our expression, but we're going to be calculating it again via this node. Let's open this up, and we're doing the same thing as we did here with the circumference, with the radius times 2 pi, right? But this time we're going to be using the wheel radius, and we're going to plug that into our input 1x. So now this is going to give us the circumference of our wheel. And then what we want to do next is we want to take our steer distance and we want to divide that by our wheel's circumference. And we're going to do that and then multiply it by 360, and we'll get the value that we can now add or subtract to our drive. So what we're going to plug in here is we're going to take our output x and we're going to put that into input 1x. And then we're going to take our output 1x here, or output x, sorry, from our wheel circumference, and we're going to put that into input 2x, right? And what that's going to do is it's going to create a fraction again, and then we're going to multiply that result by a nice standard 360, or in this case a negative 360 because of the way we've got our steering attributes oriented. Plug that into input 1x. We see it here, it gets multiplied by negative 360, and then all we need to do is plug the output of this, output x, directly into steer drive. So if we now take a look at the steering, we can adjust that attribute and our wheels should, there they go, move in the right direction and are moving based on the distance. One thing we still need to set up here actually is if we adjust our steer radius, nothing happens. So we need to connect these joints right here to our steer radius. So let me refresh this node editor real quick. I'm going to grab the drive control and I'm going to grab our wheels, all 4 of them, and just add them. And I'm also going to grab the steer distance and invert multiple divide node. So we already used that for the steering kind of expression thing we were doing just now, but we're going to just use another slot in here. We're just going to use input Y just to create an invert to save an extra node. Keeps the scene a little bit cleaner. So what we're going to do is we're just going to take steering radius, plug that into input Y, and if we open this one up, we're just going to set that to -1, and we're going to take the output and we want to plug that into our right joints only. So if we move the right ones up here so we don't get confused, and we're going to plug our output Y into a translate X of both of these. So output Y into translate X, and then these ones here we can go straight into the left side with our steer radius. So we can just grab this and go translate X and steer radius to translate X. Now we adjust our steer radius, our wheels extend, and if we steer with this, we should have our wheels spinning a lot faster as we get further away from our pivot point. We can go ahead and lock and hide these attributes now. We don't need those anymore. Everything seems to be working. Let me close this. Just going to do one final once over on this rig just to make sure we're good to go to the next part. That seems to be working good. We've got our rear wheel spin, our front wheel spin. Again, we just tested the steer radius. Our length works, width's working, wheel radius is still working. We're looking pretty good. Everything's all working great. So let's go ahead and move on to part 3. In the next video, we're going to link up the suspension and have the springs and the arms react to the motion of our body control, and also how we can adjust the rig to fit your vehicle model. Thanks for watching, and I'll see you in the next video.